All right, welcome to the Explainer. Today we are talking about something totally new, the personal AI supercomputer. We're going to break down the top machines out there to help you figure out, which one is actually the right tool for your work. For decades when you thought supercomputer, you pictured a machine that filled a whole room, right? So, can something like that really fit on your desk today? Well, the answer is a huge yes. And it's all because of one massive technological shift that is, no exaggeration, completely changing the game for AI development. And this is it. This is the secret sauce, unified memory architecture. Honestly, it's the only reason we're even able to have this conversation. See, in the old days, the CPU and GPU were on separate islands, connected by this slow, rickety bridge, the data bus. But now, by putting everything on a single chip, what we call a system on a chip, and giving them this giant high-speed pool of shared memory to play in, these new machines can handle AI models that, until now, you could only dream of running outside the cloud.
Okay, so to figure out which machine really comes out on top, we've set this whole thing up like a classic bake-off. We're going to look at why you'd even want an AI machine on your desk in the first place. Then we'll meet the contenders, pit them against each other in a hardware showdown, look at the great software divide, and then, finally, help you pick your champion.
All right, first things first. Let's set the stage. For what feels like forever, any serious AI work had to be done on rented cloud servers. So, what changed? Why is having a local AI machine suddenly such a big deal? Well, moving your AI workflow from the cloud down to your desk gives you 4 massive wins. First off, you can say goodbye to those eye-watering, pay-by-the-minute GPU rental fees. Second, and this is huge, you keep your sensitive data and your own secret models completely private, on your own machine. Third, your iteration speed just explodes. You can test, debug, and prototype instantly without waiting for some slow deployment process. And finally, you can actually meet those super strict data sovereignty rules, which is a must-have for industries like healthcare and finance.
Okay, so the why is pretty clear. Now, let's meet the who. Let's get into the 3 main contenders that are really defining this brand new market. And what's fascinating is that each one takes a completely different approach to building the ultimate AI desktop. And you can really see their unique personalities laid out here. First up, you've got the NVIDIA DGX Spark. Think of it as the Enterprise Pro. It's literally a perfect, tiny version of what you'd find in a massive data center. Then you have the Apple Mac Studio, the creative powerhouse, which uses its insane memory capacity for both huge AI models and high-end creative work. And finally, there's the Framework desktop, the scrappy, open-source challenger, whose whole mission is to make this kind of power affordable, modular, and repairable for everyone.
All right, time to get into the nitty-gritty. Let's dive into the core of our comparison, the raw hardware specs. This is where we separate the marketing hype from the actual real-world performance and see how these machines stack up on the metrics that really matter for AI. Okay, first battle, memory capacity. This is super important because it basically decides how big of an AI model you can even run. So, to give you some context, a pretty common 70 billion parameter model needs about 140 gigs of RAM. Now, the DGX Spark and the Framework, they top out at 128 gigs, which is great for a lot of models, don't get me wrong. But then there's the Mac Studio with the M3 Ultra. It can be configured with an absolutely mind-boggling 512 gigabytes of memory. That lets you run models with over 600 billion parameters. Right there, on your desk. It's just in a league of its own here.
But look, capacity is only half the story, right? You also need bandwidth. Think of it like a highway for your data. Bandwidth is how many lanes that highway has, and it determines how fast your model can actually run. And just look at this. The Mac Studio's lead here is staggering. We're talking 819 gigabytes per second. Its data highway is almost 3 times wider than the competition. And believe me, that has a massive, massive impact on performance, as you're about to see.
Okay, so to really get a handle on AI speed, you need to understand that it's a 2-part process. There's prefill, or ingestion. That's the heavy lifting phase where the model reads and, thinks about your prompt. That part is all about raw compute power. But then there's the decode phase, or generation. This is when the model starts writing its answer, token by token. And this phase is all about memory bandwidth. How wide is that data highway we just talked about? And this is where you see that trade-off play out perfectly. The DGX Spark, with its super powerful Blackwell GPU, just crushes the prefill stage. It thinks about your prompt at over 1,700 tokens a second. That's incredibly fast. But
When it's time to decode and actually write the answer, that massive memory bandwidth of the Mac Studio just takes over. It's generating text at 71 tokens per second, which is nearly twice as fast as the Spark. So, to put it simply, NVIDIA gets you off the starting line faster, but Apple finishes the race way quicker.
Now, you might have heard NVIDIA making a really bold claim for the DGX Spark: 1 petaflop of AI performance. Okay, what does that even mean? That's a quadrillion, 1,000 trillion calculations per second. That's a number that used to be reserved for those giant room-sized supercomputers. So how on earth is that possible in this little box? Well, here's the catch. Hitting that 1 petaflop number depends on some very specific software tricks. You have to be using NVIDIA's special 4-bit number format and a clever hardware feature they call structured sparsity, which basically prunes away calculations that aren't needed. For more general, everyday tasks that don't use these optimizations, independent tests show the real-world performance is closer to 500 teraflops. Now, don't get me wrong, that is still ridiculously fast, but it's not quite that big, flashy headline number.
Okay, last hardware point. What if you need to scale up later on? This is where the DGX Spark pulls out a unique, absolute killer feature. It actually has a data center-grade networking port. This lets you link 2 Sparks together with a special cable, creating a single virtual machine with 256 gigs of memory. And it does it all without slowing down the CPU. It's amazing. The Mac and the framework, they rely on standard stuff like Thunderbolt, which is awesome for hooking up hard drives, but it just can't touch this kind of low-latency connection for building a mini AI cluster.
But look, great hardware is only half the battle, right? For a lot of developers, maybe even most developers, the software ecosystem is what really matters. And this is where we see another huge split between our contenders.
And just like with the hardware, the software reveals 3 totally different ways of thinking. With NVIDIA, you get CUDA. It's the undisputed industry standard. It's like a fortress where everything is solid and it just works. Then you have Apple with its new open source framework, MLX. It's like a brand new, polished, modern building, super clean and efficient. And then there's AMD with ROCm. This is the open source garage. It's incredibly powerful and you can do anything with it, but you've got to be ready to get your hands dirty with a more DIY approach.
And this quote from our research really just nails the experience of working with AMD's software. It says, you often find yourself in a pioneer position, needing to compile your own code or figure out early release drivers. You get all this power and openness, but yeah, you might have to get your hands dirty debugging things. It's a completely different world from NVIDIA's It Just Works plug-and-play experience.
So, after all of that, the big question: which machine should you actually buy? Look, our goal here isn't to pick one single winner for everybody. That's impossible. Instead, we want to help you find your champion, the machine that's perfect for what you need to do.
You know, maybe the best way to wrap your head around these choices is with a final analogy. Think of the NVIDIA DGX Spark as your specialized cargo ship. It's built for one thing: to reliably haul heavy, compute-intensive AI projects from your desk, where you prototype, to the data center, where you deploy. Then you have the Mac Studio. That's your luxury liner. It uses that incredible high-bandwidth design to just glide through massive models, all while giving you this premium, silent, smooth user experience. And finally, the framework. That's your agile speedboat. It's fast, affordable, customizable, and it's bringing the power of local AI to a much wider audience.
And this final chart really brings it all home and should help you make that choice. So let's break it down. If your #1 priority is crazy fast prompt ingestion, software that just works out of the box, and the ability to scale up later, the DGX Spark is your machine, no question. If your job involves wrangling the absolute biggest models out there and you want the fastest possible text generation, the Mac Studio is your champion. But if you're looking for the absolute best bang for your buck on an open, repairable platform, well then the Framework Desktop is the clear winner.
So here's the bottom line. For the first time in history, you can have a legitimate AI supercomputer sitting right there on your desk. The cloud is no longer the only game in town. So really, the only question left for you is, which one of these incredible machines are you going to build your future on?